this rectangle, and then you ask yourself, how many bases do we have? In this case, we have 2. So let's draw your base. And what are the shapes of your bases? These guys are circles, so we put a circle up on top and bottom. And notice that this length of your lateral area is the circumference around the circle. So lateral area is equal to, and I could put a green, maybe it'd be helpful to do that here, this is lateral area, right? Is that right? No, that's pink. Okay, so this 2 pi r, that's the distance around this circle, and then times the height, that's your orange, if that's helpful to sort those things out. Okay, so 2 pi r is the circumference, which is the same as the length of the lateral area, times the height, and that's the height of your your cylinder. Okay, so that's the lateral area. And then 2 times the area of the big base. The big base is the shape of a circle, and you know that the area of a circle is pi r squared, and so it's 2 times pi r squared. So be careful. We're not talking about 2 pi r. That would be circumference. We are talking about pi r squared, which is area, and we have 2 of those areas. So it's 2 times pi r squared. Okay, so plug in your numbers into that dude and plug into your calculator. And I probably should put here to round it to the nearest 10th. Here I say 100th, but here we'll say, up here we'll say round to the nearest, we'll say 100th, I guess, 100th. Again, notice as a TH on the end there. I probably should make this capital. Okay, so go ahead and pause the video and do that. Now for this last problem, here we have a cylinder. That looks pretty easy. And what do we know about the cylinder? We don't know much. They tell us that this diagonal is 10 inches. The diagonal is 10 inches. And then they tell us that this angle over here is 60 degrees. Wow. So they do not tell us what the height is, and they do not tell us what the radius is. You're telling me you want me to find the surface area of this cylinder when all that you give me is just the diagonal from one edge, one point of on the circle to the center of the other big base? And the answer is yes, of course. So the way you do this is a right triangle, and in reference to this angle, we're going to do trig on this angle. You could do a special right triangle if you want to, but let's do trig to get you accustomed to that. So with regard to this angle here, of course, across from the right angle, that's your hypotenuse, right? But in reference to this angle, this is your opposite. So the height is your opposite, and the radius is your adjacent. So let's find the radius first. So to find the radius, that is the adjacent. Did I mess this up? I did mess it up. You knucklehead. So the sine of 60 should be h. Let's make this an h. Okay, is opposite over hypotenuse. There we go. And then the cosine of 60 is going to be adjacent, which is r. Can't believe I made that mistake. I shouldn't say it. I'm surprised I made a mistake. I make mistakes all the time. Okay, so you guys are not surprised, huh? So this is an r. So the sine of 60 equals the height over 10, right? The opposite over the hypotenuse. And the cosine of 60 equals, that's a radius there. That's radius. All right, real sloppy here. Radius over 10. Okay, and you know how to solve this little equation for the height. You multiply both sides by 10. Then you'll have the height, multiply both sides by 10 here. Then you'll have the radius, and then you plug that into your equation. Well, first, always draw your surface area net, and start out with a rectangle. And you know that the radius around the circumference around the circle is the same as this perimeter. So do the same thing as we did up here with number 2. The only twist on this was that we had to do some trig in order to find the height and the radius. Okay, hope that was useful to you. May the Lord bless you, and I look forward to seeing you in class.